Okay, so I'll work in another drawing. Yes, they were 2D exercises. Now I'll say 3D. So you can use a file set and say basic training. And I can move these two files here in order not to browse through a lot of files, 80 drawing files. I'll just have this. Okay, and I'll go here to 3D. And our first exercise will be this simple shape. We will use a polar system for drawing these lines. Then we'll go with the polyline through these drawn lines. And then we'll rotate it in order to obtain this this dome. It's a orthodox dome, or maybe we can call it a hat, and it's the same thing. Okay, we'll do it like this. We'll draw a simple line, or we can use a polyline, it doesn't matter. However, what is important is the way we'll enter the coordinates. Yesterday we used global point, we used then delta point, which the global point was in a absolute system geographic coordinate, while delta point was referring to a previous inserted point. And now we'll use polar coordinates. Polar will use a polar coordinate system which needs an angle and a radius in order to draw a shape. So we'll have here in this PDF to the basics I sent you, we'll have all the information needed. So I'll start from a point and then I'll enter this information. So first I'll have 53 degrees, and then with tab I'll drop in this box where I have to enter the length, which is 1 meter, hit enter, and then the angle and the length. So only using tab I'm switching between the two boxes and enter those coordinates in order to obtain a particular shape. And now the last 7 degrees and 0.93. This is the shape made using lines, so it's a bit, it has a lot of corners, it's not smooth. I'll then use the function spline, which will do a better approximation and will help me obtain this kind of shape, a curvy shape. I could have entered these points from the beginning to enter the spline with a polar coordinate system, but I wanted to show you how we can use it online. And then now it's easier to use what I've drawn as a support, and I can choose delta point and just move the spline through the existing points, and I'll see I'm obtaining a smoother shape. I can see here this object is a spline while this one is a line. If I want to move out the lines to see the spline better, I can say move, and then we have these filter functions which are really useful. I can filter by element type, and I'll say I want the what is line or what isn't line to be selected. I can choose whatever element is drawn here. This is only for basic elements. We have other filters for architecture or for reinforcement. So we have very many filters according to object category, and then I can filter objects that have this criteria or don't have this criteria. So I can choose line with this equal checked, and then it will only select the lines, or I can do the other way around. I'll say move, filter by element type, and say line, but what isn't line is different. Anything that is not a line to be selected, and I'll have this spline. Okay, now we'll have to convert this 2D spline into a 3D line, which is really simple. And now we'll use a new module, this bonus tools, and we'll enter this 3D modeling. No, I don't. I only switch modules. I don't close anything. No, I don't have to close it. I don't know why this shape is drawn here. We don't need to do that. It's enough for us to obtain the full 3D model. If we close this area and we'll do this rotation, we'll get a filled hat, so we'll have a full volume, not an empty one. Yes, it's filled inside, because it will rotate this shape until it closes, and we only want the outer edge. And now first thing we'll do is we'll convert this 2D form in a 3D form. For this I have to change the module, go to bonus tools, and this function at the end of the create functions from this module is convert elements, and I can convert from 2D to 3D. He asked me if I wanted to create them in a single 3D entity. Yes, because I can select many other objects, many lines, and do one single object. So now it's nothing special. I did a conversion, and I can see it's a 3D line, not a spline anymore. And now I can change the way I look. So this is the plan view. If I look from front, it's normal, I see a straight line. If I watch isometric view, I'll see this shape, and I can also rotate it. So basically now I have the shape, however it is 3D. So if I select here, let's say 2+1 animation window, I will see this on a white plane and this line I've created. The only problem is it's now it's situated in plan. So the first thing I'll do is rotate it to be vertically, and this I'll do using this rotate function. However, I will use this 3D in 3D because it's not a plane rotation, it's a rotation according to one axis. So I'll say 3D in 3D, select the elements I want to rotate. This element, 1 point to determine the axis, I'll choose an edge, and then I'll go in a direction for him to understand the path, the axis for which I'll do the rotation. So it will do a rotation around this axis, and then the angle will be 90 degrees. So now if I see it in 3D, now I rotated that spline to be vertically. I'm not seeing this one because it's 2D, and what is 2D I can only see in plan. That's the way it's meant in Allplan. And now here I can see that I'm looking from here is a front view of the object, here is a plan view, and here is an animation with a 3D. All I need to do now is create a rotation. Yes. Yes. Yes, I didn't select any from here, because if I had selected the spline and any line, it would have converted it in 3D. It doesn't matter the distance. The only distance important is for them not to be selected by accident. That's all. I don't even need this shape anymore. I can delete it. They don't have any relation now. Also, that spline I used to have is no more. It's transformed in a 3D line, and then it will transform in an object. Now I'm transforming it in an object using this solid of revolution function. So now this line is look, if we look here, I'm in a plan view. If I look on this spline from above, it will be a straight line. And here is the view from above, the plan view. This is the view from the front, and this is a 3D view. Okay, and now what I'll do is select this solid of revolution, and I will choose this view, and he asked me select the outline I want to rotate. This is the outline, this 3D. I'll just do one click, and then he'll need an axis for rotation, and the axis for rotation is a vertical line. It doesn't matter how long it is because it only rotates around it. So I'll choose this point and go downwards, and he'll know this is the rotation line. And now he's asking me for the divisions. What are these divisions? If I'm looking more here in this on this hat, I'll see that the circle is not perfect. It's made of polygons, and this is specific for any CAD program. A circle is actually a polygon with many edges. The more edges it has, the more it's similar to a curve and to the shape of a circle as we know it. The less edges it has, it will look more chunky. However, the problem is with the hardware. The hardware, your computer is more put to work when it has many edges than when it has less edges. And also in reality, if we are going to construct this object, we will need the formwork, and the formwork will also be made of straight faces. And we can now here approximate the circle with a number of edges. The more edges we use, the more curvy and nice looking the object will be. However, it will use more memory in order to exist. So we'll choose now a value, a decent value, let's say 30 edges. So here I'll say 30. And now the angle. I'm doing a revolution, a solid of revolution. I can choose whether I want 360 degrees in order to obtain a perfect circle, or I can do an arc, an opening in this area. I'll let it with the default value of 360 and hit enter. And then he's asking me if I want to merge the adjoining surfaces, and yes, I want. Axis is not on plane, just a second. I'll do command again. I don't know what it didn't want. So this is the line. This is the first point, the edges. I said 30. Yes, unable to create a solid. Oh, well, it did actually, and you'll see in the movie if I walk too slow. The only problem is it's white, and I'll change the color here on this pencil. With this pencil I can edit. If I want to create it from the beginning with colors, I'll use this toolbars for drawing something, but this is valid for something I'm drawing now. A new object can be with the colors from here. If I want to change colors on an existing object, I'll use this pencil. It doesn't matter if it's 2D or 3D. And I'll use, I can use this color. Okay, and then click this object, and now it's yellowish. Also, I can change the transparency. I can right click in the animation window. Wait a second. Oh, okay, no function should be select. And then I can say right click set surface and change the transparency of this color, and I'll get a transparent object. Also, I can apply a certain texture on this object, which is really easy. I can right click and say assign custom surfaces to 3D, and I can go to the office standard, or let's see here what's new with this new materials. Let's say they have something like masonry, plastic ceramics and say this. Not interesting. It's just like a white, but I'll use another one in office. Default. Well, in standard I can use okay. Let's say this one, and it placed some bricks, and I can do like this one, place different textures on 3D objects. We'll discuss on this further on. Now I created this object. I can do some changes. For instance, I'm looking here, maybe if I want to cut a part of this object, it can be easily done. I can say slice and remove a slice on this object. I'll select edges, and just by clicking any 3 points in the same plan, I have 2 objects now. For instance, maybe I want this to be concrete, and now I have 2 objects. So I have the lower part and the upper part. And if I want to change, let's say, the texture, I can easily do this. And now I have 2 different objects, or I can move certain parts of the object. And we'll have many ways of obtaining different 3D forms. So the basic, you've seen the most we needed to draw that first shape, the lines, the supporting lines. Then we did a spline. Afterwards we converted in a 3D object, 3D line, and then a 3D object. I can easily also do now an opening. Let's say for this object I'll use this cylinder function, which has a few parameters. I will enter the center point here in this plan view. Then I'll enter the corners, and I'll use the same number of corners in order to have the same number of segments. And let's say I want to cut it here. So I'll go it up until here in order to determine the radius of my cylinder. And then I have either input here the height, or I can easily draw it in any window I like. Even in animation window I can draw it if I want. So I can use this, and I created here a cylinder. And yes, well, this is the way it will work. It's no difference between 3D and 2D. I'm using 3 windows and I'm looking at the same object. Yes, I wanted to show you how we can create intersection, to remove intersection from 2 objects. I can remove it, cut it directly. I can use this function called extrusion, which we'll also use in the following exercises. And click here, extrude circle. And I want a negative extrusion. Okay, I'll hit here, select this reference surface. Just a second. No, it's okay how I did it. No, this is the way I will do. I'll show you, we can do some adjustments, some remove of materials, but this is the easiest way I'll do it. I created this cylinder, and then I'll remove the intersection between the cylinder and this hat, and we'll only have the remaining. I'll say subtract and remove solid. Click first solid. This is our first solid, and select all solids I want to subtract, and this is the solid I want to subtract. And now we're having a hole in this just by removing a certain object. Of course, we can add some thickness to this object because now we only have it as a surface and not a volume. but for that we needed to create an offsetted spline at the beginning and rotate that offsetted spline, and it would have created an object. We have easier ways of creating a dome. The main point of this exercise was actually completion for 2D. I wanted to complete the 2D training with this kind of lines where we know the angle and the length of the segment. And then the important way of going from 2D to 3D. So this is not just the beginning of 3D. But for this shape we can easily use some other objects, smart parts. I'll show you later on some parameterized objects which can be easily edited. I can edit this as well. I can change points from it. However, they are triangulated surfaces and won't do exactly what we expect. It will do something but not what we expect. I'll show you with smart parts how we can do many changes to this kind of object. I'd like now to go further on with this basic exercise, and then we'll do this shape, and I'll also show you a movie, or I think I can do it, how to do a more complex object, a bridge, because I know you're interested in bridges, how we can model let me see if I find how we can model I don't have it here, I have in Allplan 2014. I can model the pile of a bridge, which is really interesting as a shape. Yes, well, if we needed the stick, there is no size. Yes, of course. Yes, it can be easily done. However, I'll do it. It can be done like this. I have the supporting points. I only need to create the spline again. Okay, now that I have the spline, I'll create a copy here. I will do an offset. So I'm working now only in 2D. I will do an offset. I'll choose this line, just a temporary line, and then I'll do an offset with the thickness I need. Let's say 10 centimeters. So click on element. This is the element. I want an offset of 10 centimeters on this side one time. So I'm doing the offset, the function you already know from 2D, and I'll also do here an extension. So I'll say intersect two entities. I'll intersect this spline with this line. Okay, if it doesn't work like this, I'll just move its last point, and also remove this extra segment, and now close this shape. So the only difference is that I needed to offset it with the length. It's still a 2D shape. Now, in order to make it 3D, we'll do the same basic steps, bonus tools, and say convert elements from 2D to lines, from 2D to 3D lines in a single object. This is the object. And now I will raise the object. So I'll rotate it using this freely in 3D, choose an axis for it, and say 90 degrees. And if I rotate this shape, it will get me a closed volume, and it will feel this existing. Okay, now we will say create a solid of revolution. Select the outline. This is the outline, and now the axis can be this line actually. How many? I say 30, 360 degrees, and unite this in an object, and we can see now. Okay, I'll change the color of it in order to see the shape, or I can generate a section through it in order to be able to see its thickness. We'll get later on engineering, but now I'm showing just to prove a point how we can do these sections. So if I create a section here, it will have a thickness of I set from 2D. If I'm doing a section through this object, it has no thickness. So the first one was only a surface, while the second one is, the first one is a surface. However, it's harder to see because I've selected a part of it to show. Okay, I'll do it like this. I'm doing a section from this side behind, and I can see here the feeling of it. I can also complete here to see, let's say it's a concrete surface, and we'll see it has some thickness in it, while the first things I've shown you was only a surface, not a 3D object. So it would have only had an edge. So this is basically how we would do. What I'll show you now, but I'll also show you later on, is a more advanced way of introducing this kind of dome, where we can use some smart parts. I'll just change a bit the interface palette. I can use from library. I can use a smart part from the office, from the default 3D object, and I can create this dome, which is similar, not exactly but similar. But this dome has some advantages. The main advantage is the fact that it's parameterized. I can change here the radius. Let's say it's 20 meters. Well, it's very big at 20 meters. Let's say 5 meters. And then I can choose the thickness of it. So this 3D object, I can then change thickness just by double clicking here and say make it smaller. And then I can choose how discrete it should be, how many division it has to have. I can change the angle from here, so it's easily done, or from here. The radius is changed like this. So this is another way we can create, and it's far easier than the method. However, these smart parts, although they are really attractive, they are limited to some simple shapes. Here we have something extra, some curved shapes, not just a dome. And this is why I also shown you how we can manually do a 3D object. So this can be our first 3D object we've done together. And you have the movie, and the exercise would be to try to do these two hats as well on your own using the movie. You won't find the written material on this object. However, I think the movie will be enough. Okay, shall we move further? Okay, and I'm going to call this exercise the hat, and I'll do another exercise, let's say castle, or I don't know how can we call it. And again, I'll show you an easier way to create 3D objects, still starting from 2D drafting. We'll do this basic form. So this can be 8 by 8. I'll start drawing in the basic modules. I'll do first a rectangle of 8 by 8 meters, 8 tab 8. And then let's see, I need the 5 and then 10. So I will do a line here, which is 10. And also here on from 5. So we're doing here again the basic part line. I want 5 meters, so here 5. Hit enter. And also this line was 5 meters from this point, so I'll say 5 meters. I'll remove the extra lines using this function auto delete segment, part of element here as well. And now that I have this simple form, I will use the mirroring functions. I will choose this, hold a bit until I see the blue crossing, and then I'll do the first part, and then also here is 20 meters, so this is another way I can manipulate objects. If I choose here a line and I see it's 926 and I want it 20 meters, I'll just say here 20 and it's changed. Also here I can use another function, stretch entities, and choose this point to be as far as the other point I just changed. So there are many ways of changing this. I'll also see now copy a mirror for this file object, and I want to enter this interior rectangle using based on center. In order to pick the center of this object, I will do like this: close to this edge, right click and say midpoint, and then it lets me draw a yellow segment and I am snapping to its middle. So if I'm drawing the segment like this, it will be the middle of it. If I'm doing diagonally, it will be the middle of this entire form. And now I only have to enter its parameters, the length. The first one is horizontal, so it's 18. Then I hit enter and say the other dimension, which is 8. And now I'll only need to do an offset of 2 meters with this parallel lines. Hit once, parallel lines 2 meters, and inside 1 copy. So I created the most complex part, the 2D, and now the 3D, it will be really easy to be done. First of all, we'll get back to the bonus tools, and we need to convert these 2D lines in 3D lines. And I will do this with convert elements from 2D to 3D in a single. Then I hit right button of the mouse, right click, in order to have this sigma for sum. This will if I right click this function, I say right click, it will show me this sigma function, which is actually for sum. Can you hear me now? Hello? Okay, now I can hear you. Okay, I said I used the right click just to be able to select the outer side. Okay, now in order to be less confusing, I'll do a setting now here in this window, not to see a plane, a supporting plane, because it's a bit confusing right now for you. Surroundings, and I'll deactivate the ground plane. Okay, so this is what I created. I only converted the edge elements, and now I'm going from 1D to 3D. 1D are the 1D elements, which are these 2D lines. To become 2D elements, I'm going to convert this into a field surface using this 3D surface and using the first function, 3D surfaces from existing 3D lines. I'm hitting this 3D lines. Now it became a surface, and the only thing left is extruding this option, so this shape. So I'll do like this in this window. I'll say extrude, select this surface. I'll choose this extrude surface, select it, and just have to enter the height, which is 55 meters upward. Enter. Just a second, I don't know if it was 55. Okay, now it's 55. And I also want to do I want to remove this central object. I see here I need 5 meters to be cropped from this initial object, and I'll do it still with this extrude function. I will just a second. I say extrude function, and I'll choose extrude rectangle. I'm selecting this surface and I'm choosing this rectangle. I'm drawing it here, and if I'm going downwards, it will remove. So I'll say -5 because I wanted to remove this central part with 5 meters. So I did an extrusion inside this object using this extrude function and said extrude rectangle. You'll see it on the movie. You can pause it if I move too fast. And the same function I'm going now to do this in the center of it. After I removed this first 5 meters, I want to do a full hole through this object. I'm with the same function, extrude. I'm going to choose this, create the rectangle in the plan view, and then in this other view I can say how much I need it to be cropped up until this point, and now it's empty inside. So I created this shape. So this was done pretty easily from 2D, and this is really important because still many architects work with 2D. They start from 2D objects. I'll show you next time how we import the bridge from 2D from AutoCAD, and how we will create a complex form using Allplan and starting from 2D from AutoCAD, and then we can compare with different views of this object. You'll see it's pretty easy to do, and we are closer to what you're interested in, which is roads and bridge design. However, we'll also do some architecture, because you'll see it's really playful. It's like you're playing Sims when you draw architecture in Allplan. It's really easy. The 3D aspects are more complex than the architecture we usually need. But for some shapes, usually for bridges, we need to know also the 3D modeling, which you see is basic. It's based on 2D as well. The only difference is we have to add some dimension upwards. Okay, any questions now? Okay, but the recording will be clear. Yes, because it's recording on my computer, so it's no lag. I'll only do this last exercise, and the homework will be for you to do this 3, and you'll have the movie as well. And tomorrow we'll start importing from AutoCAD the bridge and model its shape. Okay, so we'll do it like this. I'll first draw this 2D shape and then use extrude in order to obtain this particular shape. And I'll enter a new drawing. Just drag and drop it here. Oh no, pillar. Maybe. And start this basic 2D. So I can say polyline, and I'll draw it only half of it and then use mirror. Also, I don't want to draw it with red, it's too aggressive. I'll say gray maybe, and then I'll go 0.6, and then I'll go downwards. No, downwards will be 9 millimeter, 1 centimeters, 0.4, 0.9, 0.09, 0.2, 0.4, 1 meter, and then I have this, which is 20 on right, and downwards 3 meters. So on delta x, I'll use 0.2, and on y minus 3 meters, and then I will go up until I meet this middle of object, and that's about all I needed, because then I'll use copy and mirror and draw this shape. Now this I will do the same operations as before. Go to bonus tools and convert these elements from 2D to 3D in a yes, those are 2 extra objects, and I'll show you with a different function how we can add. This is actually, it can be for a bridge where we have the concrete structure, and these are metal objects that can be changed, and are on them other beams, girders, steel girders are placed. So these are replaceable objects, and we will create them as well. So these are 3 objects actually, the concrete and the 2 red objects. Okay, now after I have done this basic 2D shape, I will go to bonus tools, convert it from 2D to 3D as lines first, and now I can see the outline. In order to become a surface, I say 3D surface with 3D surface from existing 3D lines, and now it becomes a surface. And then I'll use extrude, and I won't use extrude in plane, I'll use in this view because it's more intuitive. And then the length will be 0.4. I extruded the object. I need it to be vertical, so in order for it to be vertical I need to do this rotation using freely in 3D. Choose the object, choose the rotation axis and the 90 degrees angle. This is the shape of it. And now indeed we need to complete with these 2 red objects, and we'll draw them in 3D. It's not difficult in isometric view. I'll use another function called box, because this is a very simple object, it's a box. I'll say box, and now I can choose the way I enter the first rectangle, and then I'll have to say the height of the box. And also, in order to have the same colors, I will do this, I choose here red, and then select first the base through 2 diagonal points, and then on the height of it I can indicate a direction and say it's 0.1. So it will be 1 centimeter above the concrete part. And then after I create this 3D object, I can use the usual functions. Let's say copy, select here a good point, and then copy it right here. So this is what I needed to create. I have here a front view of the object. Here is the view from above, and this is an animated 3D view. And basically this is how we create this object. As a bonus, I'll show you something extra. There is this, we will use, starting from tomorrow, after we model a bridge together, an element for a bridge. There's also this, we will also learn how to do automatically detailing of this object. We will be able to do like this, create a front view with, let's say we're watching from downwards, we are in front of the object, and also add some add notations, automatic add notation to it. Let's see, front view, and I wanted to do some automatic dimensioning of it using this architecture in 3D for a scale of 1/50 to 50. So we have this some automatic dimension lines. Also we can see some what is hidden behind. Just a second. Yes, and we'll talk about more tomorrow how we see if there the difference between some objects. We also can we'll be able to enter if we needed surfaces for them. but we'll detail it more after we start doing tomorrow the importing from AutoCAD, which is really important, and then the modeling. So we start from something already done in AutoCAD, 2D model of a bridge, and then we'll model over it the 3D object and generate automatic drawings for it. It will be interesting. However, I need you to exercise what I've shown you today, this basic 3 exercises, without this part, without these sections, because we'll discuss in detail. There are many settings, that's why I don't want you to try them yet, and it will be easy as well to do things like this. You'll see it's really easy to. Okay, so what I want further on. Okay, further on, I'm going to show you also what we're going to do tomorrow. I can also send you the movie if you think what I've shown you it's easy and it will take you little time. I can also send you a movie for you to explore what I'm going to show you tomorrow, and if you manage to do it by your own, I'll be real proud and I'll show you even more things. If you don't, well, it's no problem. Just a second. I'll show you what we're going to do tomorrow. And I also have a movie of it done, but we'll do it and we'll do it together. This is for just a second. We'll do this tomorrow. It will just be a combination of what we already know, we've studied today, and you'll exercise as homework. This is the pillar of a bridge, and it's an interesting form, and these are views from above, and these are some sections through it, and we will create a 3D model of it. I'll show you what it should look like. Okay, without that, in another version, and we'll do that tomorrow. I don't have the movie, so we'll just do it tomorrow. And after we finish doing this part with 3D and generation of section, we'll do some architecture as well. You'll see it's really easy to do architecture, copy floors, draw windows, openings. It will see it's nothing special. So we'll do this objects tomorrow. We won't start with reinforcement tomorrow yet, but we'll do reinforcement as well by the end of the course. But we'll do something like this, which can be, it's not a full bridge, it has some girders that need to be added. However, we'll do this particular form because it's pretty interesting, and you'll be able to do it by your own. And this is already something for bridges. So if you know to do I'll show you how we can obtain this form from scratch, from zero, and it will be really interesting. And also it's really important to know how to import these DWG files. So we'll use it as a support for snapping points, and you'll see it's really interesting. Also, DWG will help us if we want to draw. We have a 2D plan of a house. It will take very small time to model it in 3D and get the exact quantities, get automatic drawings for it. It will be really interesting. So this is what I'm planning for tomorrow, and this will be your homework, just to do the 3 exercises, and I'm sending you the movie. If you have any questions left. Yes, okay.